We're going to graph the graph of a logarithm by first graphing 15 over x, and then we're going to 15 to the x power, and then the logarithm base 15 of x, which is the inverse of that. So let's go ahead and put our coordinate axes here. And I suppose one thing we should be careful of is not to try too much. If we put in, we could put in -2 for x, and then f of x would be, let's see, 15 times 15 is 225, and it's underneath 1. So 225, pretty tiny, might as well be 0. -1 is 1 over 15. 0, anything to the 0 power is 1. Anything to the 1 is itself. And we're not going to have room to show 225 on this graph. We're just not. Okay, so let's see. We have, we'll say, -2. Maybe that's silly. No, I think we'll do -2, -1, 1, 2. Pretty tight quarters there. And then we'll try to say 5 and 10 and 15. All right, so at -2 might as well be 0. -1 might as well be 0, really. At 0 I'm at 1, so we'll be right here. And then at 1 I'm at 15, so and then I'm way too far up there to show. And the way I'm going to do this, of course, is I'm going to graph y equals x, and this assumes that my scale is the same in both directions, and if I did a good job, that's true, and if I didn't, it's a little off. But when I think about the log base 15 of x, I know that exponent can be negative, but it won't make 15. No matter what I do for 15, I can't make x negative. So m, or in this case g of x, maybe I should just say that. Maybe I should say 15 g of x. That's an exponent, right? And I'm supposed to get x. Okay, well, I know I can't go negative, okay? So there's no way that x can be negative. Even if g of x is negative, way down here, see down here? Even if it's way down here, it doesn't matter. I can't make x negative. And then when I get up to, when my exponent is 0, x is, that'll be 1. That'll be my desired result right there. And then I didn't graph my, it would help if I do this, okay, so I can show you that this guy does, you can see that they're the same on each side of the line here. They're inverse functions, okay? All right.